Yo, yo. What's up, guys? Wait for some people to show up. What's up, guys? Wait for some people to show up. Oh, I should mute that, otherwise. Yeah. Alright. I feel good today. Today's a good day, don't you think, bro? A good day. So yeah, we're going to be playing some pwnable.kr. It's a Korean pwnable site where they have pwnables. And I tried playing a few nights ago, and I didn't do so well. So let's try and see if I can do better. I'm gonna go get a cup of water, but I'm not leaving you guys, don't worry. I don't think I have a cup though, so I'm probably gonna like cup my hands and go and drink the water, you know? Yeah, I've lived in Mountain View for like 3 months. And I still don't have a cup for water. I'm going to Burning Man like tomorrow, and I'm kind of not looking forward to it. It's going to suck. If Burning Man sucks, you're in the desert for a week, and there's no like computers. I don't even like computers, but I don't like the desert either. I just want to like float in a large bath of water and just relax and be able to think about stuff and be able to program just by thinking in a magical programming language where like whatever I think turns to code. And it doesn't matter how ill-formed my ideas are, the language will take them and transform them into beautiful concrete things that I can use. We have 6 people at. Oh, my levels? Okay, hang on. I can fix that. Let's turn up the input volume. Is that better? Is that fixing my levels? Alright, cool. Better? Yeah. So we got that. I'm talking kind of low too. I don't know. I'm not drinking any caffeine today, like normally. Oh yeah, so I'm not a Google intern anymore. I was a Google intern, and my internship ended, and now I'm not an intern anymore. But maybe next week I'll be an intern again, and I can have a new internship. Alright, so yeah, I'm gonna get that water, and then we're gonna start hacking. We're gonna go hack some shit. It's gonna be fun. I'm streaming in 1080 today. I went out of a cup. I'm out of a cup. Yo, if you guys haven't seen this is pretty sweet. Here's my Chromebook Pixel. Check it out. Yeah. I wish this thing had a longer battery life and a bigger screen. If you watched my stream the other night, I'm very upset about the backlight bleed on my MacBook. I'm going to take it to Apple and get them to give me a new one because that's unacceptable. Yeah, so water and then hacking. No cup, cupless. Alright, cool. What does this do? Edit panels. Oh, I can add a panel. Cool. Yo, I am geohot. geohot.com. Panel title. Panels. Oh, you can't see this. I'm like adding a panel. Twitch isn't very responsive. Alright, let's hack. So yeah, this pwnable.kr. This is some Korean website. If you guys can't read anything on my monitor, you should get a better monitor because I'm streaming in 1080. But no, I can do a few things for you. Do this. Yeah, I'll just like that. Alright, cool. Got a bit of zoom on that. And I can't read that on my phone. Alright, cool. So yeah. See what we've got here. I just gotta log in. Oh, the site does not work well in Zoom. Alright. Should we do brainfuck or should we do OTP? Let's play OTP. Not a race condition, do not brute force. I wasn't planning on it. I think that. No, I don't want. Stop. OTP. So it's SCP that home so I can read it with. Syntax highlighting, okay. Oh, report. Usage, OTP, passcode. it gets generated with some temporary file name. And it writes it to the file. And then it reopens that file. Reads 8 bytes from it. But it reads stir.ul bytes. Oh, no, it's just ul that RDB. Both passcode. Unsigned long, okay. Okay. So it reads 16 bytes from geohot. And it writes them to an arbitrary file name in temp, which I can't control. And temp has a sticky bit set. Alright, who sees how to solve this? Read. Okay. It doesn't check that fread succeeds. So if I can make the fwrite or the fread not succeed, if I can somehow zero out that file really fast. Because I do notice that it's initialized to 0. I don't know how to do this stuff. Let's try running it and see what happens. OTP 0. OTP generated, OTP message. Just verify with strace it's doing what we think it's doing. Yeah, it opens some big stupid file in temp. Reads 10 bytes from it, and then does a compare OTP mismatch. Okay. So, I want to note that it is a world readable file. If only we knew the name of it. But because it's in temp like that, we can't know the name of it. It's a real, it's not like shaduring to temp or anything. It's a real path. It's not a race condition. They even said that. It looks very race condition-y to me. Oh, what? Why is there a 16 there? And an LU there. Alright, so whatever it is, I have to put it in hex. Hacking is exhausting. Okay. Printf, when it gets a slash, is probably going to flush. So even though I could probably delay the program's execution at that point. If the space is big though. If the space were only 32 bits, maybe I could like try them all. No. Let's take a little bit more look at the temp directory. Well, I can't list the directory contents. And that's because it's owned by root and I only have W. I'm kind of thinking it's like iNotify or watch or something. Let's see what iNotify is. Monitoring file system events. And the directory is can I use this? I notify on temp. Currently it's a okay, I guess I don't have I notify. Do I notify on my Linux box? No. Cool. They have some sketchy looking source of the iNotify program. Of course it doesn't build. I don't need that. I guess I don't need that. Permission denied, okay. Alright, so if this were a real CTF, I'd move on to another problem. This is a trick here and I don't see it. So that's exactly what we're going to do. Let's try to find one that's actually remote. Here. Move on to Writeup. And they're nice enough to give me a libc. Let's quick to them. Okay. So I can increment and decrement data pointers. Okay. Sounds like a perfect problem for Kira. Can I use one at a time? No, just okay, cool. Just runs it like that. Pull the latest updates. Wow, internet. You suck. Alright, cool. Let's open this in IDA as well. So it looks like it just reads in shit, stolen, 1 byte overflow, whatever. Do the stack cookie doesn't matter. Do that fuck, alright, cool. So yeah, this looks super easy. This has a data pointer. Let's move it. If I erase a law or anything? Wow. That has NX but no PIE. So I think we just trash the GOT. My bank reference again. The data pointer, decrement the data pointer. Why is P minus 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 1? Why doesn't IDA know about pre-increment? Like, why would you do a post-increment and then subtract 1 from it? But yeah, either way, this looks real easy. So let's bring it up in Kira. What? No, it's dash S. Let's just open up, solve, input socket. You know, I have a template for this. I should use the template. Just get in that habit. cp-slash/templates prone to solve.py. Cool. A simple template, like there's really nothing here. Cool. So let's send it some of those data pointer decrements. Cool. So this is the data pointer decrementer, subtracting from the data pointer. So here's the data pointer here. We can cycle through them with you and I. Alright, cool. Just moves the data pointer. Yeah, it looks easy. Starts out at, alright, so where's the GOT? Oh, the GOT's right above it. Okay, cool. So it starts out at A0. So in order to overwrite the GOT, Oh, and that's why they give us libc, because we're just going to move a got entry a little bit. Oh, wow, this is the easiest problem. Cool. So we're starting out at A0. Check it out. Look at how Kira's showing you the register and everything. Shiny, like it's right there. See? You see the register? Cool. Alright, so we'll start out at A0. Which got entry do we want to overwrite? See what we have in the IDA. We can overwrite any of these. Right? So getchar hasn't been used. fgets has. What's going to be the easiest? Where's puts used? Choke and choke not supported. Putchar is going to dereference and call it with 1 byte. Well, that's annoying. Well, let's move puts. Let's try that magic addressing system, and maybe we'll get lucky. Okay. So we'll overwrite the got for puts, which is where? Not disassemble, no. They got for puts. Okay, so that's a real one that's really actionable. Then what do we want to do? Okay, so first we want to move to there, and we'll do that with times A0 minus 18. Then we want to, we can decrement or increment with 0 and 1. So what was the old value? It was A0. Yeah, that's in the wrong libc. Let's do it for my libc first. So my libc is here. And if we read elf -a grep, don't grep that, read elf -a that, grep that, puts at. Alright, cool. So this is the base address of puts. We want to go to the magic system address. Not the real system address. There's a magic system address. So let me tell you, if you don't know, about the magic system address. The magic system address is really sweet, and it's magic, and you can just jump to it, and it gives you a shell. And it's always what you want to use because it's magic. But see, here's the problem. Even though you always want to use it, it doesn't always want to work. It depends on like your stack having zeros in the right place or some crap, and you don't want to deal with that a lot of times. So the magic address doesn't always work. But whatever. Let's hope the magic address will work, and if the magic address doesn't work, we will deal with that bullshit later. Alright, cool. The nice thing about the magic address is if it works in one place, it works in every place. So like, it's not like it's going to be libc dependent or anything. Alright, so here we are in system, and there's the magic address. Which one of these is actually the magic address? Moving shit from EBX. I'm always moving shit from EBX. Crap. EBX has to be something sane. What is EBX? That might be sane, I don't know. Yeah, maybe that's right. Alright, cool. Let's try jumping there. So, the address we want to jump to is... Stupid IDA. 4036B is the magic address. So, it looks like if the first one is A0, we have to subtract... Oh, whatever. I don't know what to think. I'll just subtract A0 minus 6B, and then we have the dat. Pluses here. We'll just move the pointer that way one, and we'll move this that way. We have to subtract 62 minus. Yeah, let's just hope this works, because otherwise I'll have to code something more generic for this, and that sounds shitty. Alright, cool. So 6, and we can move that to 4. Alright. Now, we send that with a /n. Oh, we also have to finally call it, so we call it like that. And clear that run, and it's off. Alright, crash. Where to crash? Well, let's see what this got entry was by the end. Which got entry trying to overwrite? But also 18, so it's there. We wrote to it a lot of times. Yeah, I think it'll work. Okay. So, jump keyword pointer. It crashed. So it tried to jump there. Who knows if that's actually like the right pointer. Let's just have keyword trace libraries. Okay, so it failed on that EBX crap. This EBX is like 120. Oh wow, that's great. That's not gonna work. Okay, magic address isn't gonna work. Alright, so what do we do if magic address doesn't work? Well, gonna have to figure out how to ROP. We could probably leak shit. But that sounds crappy. Writer font is a little small. Okay, I'll make the writer font bigger. Writer font big. Is everyone happy? Cool. Not happy. That sucks. Because I'm happy. I'm always happy. Alright, well, it didn't work very well. So the magic address doesn't work. I'll make this writer font big too. There's font. I better make them the same big, otherwise it's going to bother me. That looks the same. Alright. So we get function calls that have nothing. Where does this puts come from? Is there any way I can change that string pointer? Offset pass. No, pushes that straight up offset. It's an RO data, so we can't change it. This is tempting, so all we're going to really get is a byte there. So we get a byte we can control, useless. There should be a function in libc that just runs binsh. That would be a nice function. Like, think of all the uses. You could jump to it when you're exploiting things, and you could, I don't know, that's really the only use I could think of, but I think it'd be a useful use, and I think we should suggest that to the libc maintainers. If anyone knows a libc maintainer, tell them about the function I want. We'll call it run binsh. No underscores, just like run binsh. And you just call it, and that's it, you're done. Okay, well, what can we do? We can do crappy things with, like, stacks and stuff. Like, build a ROP stack. Do you want to build a ROP stack? I don't want to build a ROP stack. No, that sounds hard. Okay, well, where does EBX get set? Not like anywhere near anywhere. Well, actually, let's talk for a second. What if I call system with that junk, then call system again? Does EBX get used? It doesn't get used, then it'll stay the same. EBX, no, EBX gets used there. Oh, it gets used for bullshit, too. Oh, actually, no, it won't get used, because it's all in the do brainfuck loop. So, what if we just call system, and that'll prepare EBX how we want it, and then, even though that system call will fail, whatever, we don't care. Okay, let's try that. So there's system. It's at system. So, oh, we have to add now. Let's add co minus a, and then here we still have to subtract. We don't have to subtract it there, and that stays the same. Okay, so that'll call system. Call system to set EBX. Alright, let's just verify that that works. Here, you don't need to trace into libraries anymore. Because you're slow when you do that. Alright, cool. So sh missing blah, but we're gonna get exec back. Yeah, we get exec back and returns. Okay. So now we have to call magic. When we call magic, we'll just... the pointer's there now, so that pointer can stay the same. We'll just move it 2 over. Depth equals how much we have to move it. Minus 0 minus BC. Then we have to move it 1 this way, and then we have to just go 1 back. And then we have to call that again. And then we have to move it 1. Move it 1 back. Call magic back. Cool. Let's try that. That window, that window. Seg faults. Oh, screw you and your seg faults. Right here, trace libraries. But where's EBX trashed? Who broke EBX? Push EBX. What? Comp EBX ECX. Oh god. Do brainfuck runs one thing at a time. Okay, that doesn't work. Alright, what registers do I have control over when that thing gets called? This is the call. Not really. It's EDX. Oh, EDX is my brain fuck. Wow, that's interesting. Actually, the brain fuck is on the stack. Alright, let's ROP. Well, let's look at something first. So, let's go over here to this. Oh, but that's not going to work because I don't actually know addresses until I leak them. Alright, well, we can leak them and we can jump back home. Do we have PIE? No, we don't have PIE. Default is return. It's not going to work anyway. Well, okay. So what I can do is put crap further down the stack. Not useful. So the problem is, once the program starts running, there's no real way to influence like what happens next. Too bad MX is on. What do I do about that? Alright, we have to build a ROP stack. I wish there was a function in BrainFuck that would just print out what you're doing. All right. Is string length really called every time in that loop? Yes, it is. What can I do about it? Can I take advantage of that? That's at least going to be called with an address. Yeah, that's going to, no, it's not called with that address. It's called with, I should be stack address, never mind. Because we could rewrite the program if we knew the program's address. Now we can't really do that because it's too far. I don't want to send all those characters. Yeah, unfortunately, the words bin sh, what we could do is we could like stick a bin sh semicolon there and overwrite strlen. But well, let's just strlen. Let's enter here and see. All these calls are being called with that. Problem is okay. Well, why am I even doing that adding? I could just do get chars. Just do put chars and get chars. I think P is actually a pointer that we can overwrite. Yeah. We could overwrite that, but the problem is the second we overwrite that, we can't overwrite it anymore. We get one overwrite on that. It's annoying. Alright. It's P. Standard in, standard out. Oh, did you ask for permission? No, I didn't ask for permission. So I think that it's a website that you navigate to on the internet. I don't think that you should have to ask permission to stream browsing of the internet. I think that the other folks who had a problem with it, I think that they, yeah. If you have a problem with it and you ask me to stop, I'll stop. But I don't think the culture is to ask permission. Like remix culture, I think the culture is you do something, and if someone has a problem, you'll take it down and you'll be polite about it. But this asking for permission and waiting for permission, I don't really think is the culture of intellectual property that I believe in. So yeah, you know, I didn't ask the other folks for permission either. They got very angry with me. That's on them. So yeah, I don't think that this is a write-up. The problem with a write-up, I think that a write-up and a video are very different. The problem with a write-up is that it's Googleable. You can Google, and that ruins the problem, right? Because everyone's going to Google, and they're going to accidentally come upon a write-up, whereas a video doesn't have that problem. If you're looking for a video, you're actively seeking something out and watching it. And at that point, you know, the problem is the accidental Googling. It's just so easy in a write-up. If there's like a special word, someone hits upon it in Google and it ruins the answer. So that's why I feel that a write-up and a video are very different. So yeah, if anyone has a problem, of course I'm happy to take it down and stop. but I don't think the default, I think the default is permission because it is a website on the public internet. So yeah, that's my addressing of that. Cool. And that being said, too, just as a side, not really relating to this, but yeah, websites thinking that their terms of service are magical and binding. You can go back to like Lori Drew and MySpace. Come on, we can't live in that world. All right, back to solving this problem. So we can increment and decrement. We can put chars and get chars. We can leak libc. Once we've leaked libc, we can build a stack. The question is, where do we build that stack? Wherever I jump to is going to be... Oh, that's so annoying. Alright, so we can put things later down on the stack. So let's just... okay, I know what we do. We add, so forget this magic calling. The only thing we're going to need to call is that's strlen. We're going to need to call system. Okay. So instead of strlen, we call system. And then the thing we execute is that semicolon sh. All right, that should do it. So now we need to replace system. We need to replace strlen instead. So strlen is at 20. What is strlen by default? 93ac0 is strlen. That's system. Oh, I'm doing this so badly. Okay. Whatever. Strlen and system have the same last byte. We'll just leave that there for when they don't. We need to subtract 9a, 4, and we need to subtract here 9, 4. Alright, cool. Let's try that. Didn't work. Alright, so now we're in AC0 is the system. I think that's system. It's not system. What did I do wrong? No, fork. Okay, let's just clear that and redo it. We have a lot of writes to that. What is it at the end? 9C0. Is that system? C9 C0. Okay, it's just wrong. Yeah, 9-4. That should be right. That's strlen, and that's well, actually, it's probably not strlen. Where's strlen in here? Wait a second. What kind of libc doesn't have strlen in it? It certainly doesn't misspell strlen. Strlen G? Okay, I don't know why there's no function called strlen. Wow, okay, fine. AC0. 93AC0. And system would be Here's a function called puts. I don't understand. Like, here's my libc. Here's a function called puts. Where's a function called sterling? There's only this sterling g, which doesn't have the same n bytes as the function called. Okay, fine. We will search for bytes. So what I could probably do is rebase my libc, and then Kira would just find it, but it sounds like effort. Wow. Alright, there's no sterling. This is sterling. Cool. Thanks for not exporting anything. So that's going to change to 8c, and therefore this instead of 9 becomes 8. Is there a shell yet? No, still no shell. What? That system? Okay, you know what? This is a stupid way to do this. Let's just do this right. Let's read and then write. So we just dat plus equals dot that'll output the thing. And then we want to read in the thing in the opposite direction. No, you know what? Make that easy, please. Text libc. Okay, it's trying to into 4. Oh god. Okay, let me update my template. Hang on. Ricky always does this. F equals s.makefile. And then we just replace that with f.read4. Oh, actually read 4 bytes, right? Cool, read 4 bytes. Except, what the hell? 5? That's better. That's a libc address. Libc equals q that. Now, we're just send it back. We say s.send. I should just s there. Q libc, except for the fact we need to change it. So libc minus equals that. Libc plus equals that. S.send libc. Correct. Alright. Go. Crash. Or crash. Kira, stop tracing libraries. Should just have a toggle for that in the web interface. Alright, we're jumping somewhere. Jumping there to CD80. Is that what I sent to it? I don't think that's what I sent to it. Oh, fine, I went in the dot. This is what I sent to it. Why is get char? Why is it called a get char breaking? Are any of my chars getting received? No, my chars aren't getting received. Calls to get char are seg faulting. That better work. Okay, cool. Alright, fine. Don't work at all. Oh man, alright, fine. Sometime I'm getting a enter there, and sometime I'm not. Let me just fix that R until up to be that, and then just change that to f.read4. That should fix it, maybe? Work? Alright, cool. I'll modify libc. Now we're seg faulting again. But let's at least hope we're seg faulting somewhere more intelligent. Alright, cool, we're jumping there. Choose libraries. Okay, where am I crashing? That's like not system. I don't get it. I subtracted strlen. What's the libc load address? Right there. Okay, that actually makes perfect sense for why that's strlen. Number sent me was that. I'm gonna change that number to system, which is that, right? Like I didn't. That looks right, except for the fact that it didn't jump there. 904C0. Yeah, that's clearly not that. Okay, so that's exactly what's being sent. Like, notice how that's the same as that. And then, like, Python does math, which isn't wrong. And then I rewind it 4. It's making me a jump. What's that set to? 904. What? How come it didn't change that one? Was it 9? Get it. Oh god, because it's calling it each time. That's frustrating. You see what's wrong? You'll see. Like that Sterling gets called every time, so that's not going to work. It's frustrating. Okay, because that Sterling gets called every time, and I have no way of controlling when it gets called, I actually get no control at all. Like, because it's called every time in a loop, right? Alright. What else can we do? Like, we can do something like replace memset and then jump to the beginning. But that's not very helpful. I'm just going to run some arbitrary chunk of stack. Like, if we could replace Sterling for the net... If Sterling wasn't in a loop, that would actually be much better here. Because then we could hijack the pointer and jump back to the beginning again. Alright. Let's see what the registers look like when this put char is called. EDX is the string. System doesn't happen to, like, use EDX, does it? There's no, like... EAX, no. Yeah, it's just crap. No. Let's see. Puts. Okay. Sterling needs to do like anything but side fault. What if you try it the other way? Can I get lucky? Of course I'm not gonna get lucky. That was a stupid idea. Okay. what if we jump to the fgets before, what if we jump to the fgets right here? Oh, it just didn't work. Oh, because I'm not, okay, I have to re-override puts instead. Re-override that, do that there, that plus equals that, alright, cool. What am I being called with? I understand, that should actually kind of work. Calling that with that should actually kind of be exactly what I want. That should smash the stack, right? I don't know why it crashed. That totally shouldn't crash. That should actually work. Like I'm calling fgets with a valid stack address, a big ass number, and 0. Oh, it's fgets. 0 is not right because it's not a read, right? Alright. Well. Turning that into a read or something isn't going to work. Overriding Sterling isn't going to work. It is. Wow, you know, you think this problem is going to be easy, and it so isn't. Well, you can jump back there with very little penalty. It didn't even work. Right there. When did that work? Oh, because puts is corrupted, and every time we're calling puts. Fair. That's fair. We're looping. Okay. So let's go here and try that. That's what. That's good. Aborted? What's that mean? Stack smashing detected. This is a freaking stack cookie. Oh, yo, stack cookies. Stack cookies really make me mad. If you haven't heard, yeah, I really hate stack cookies. Like, I really hate them. Okay. Well, so now I know what we can do. Alright, now we can actually build a real stack. Let's just here, we'll fire off my replacer. Okay. The trick here is what we have to send is that equals. Oh, I don't think that changed. It's the same. So yeah, what we're gonna do is now that we have a libc address leaked, we can just pivot the stack. Alright, cool. We have a libc address leaked, we can just do so where'd that go? We'll rewind. We need to rewind, resend. Do that. It's stupid. We don't need it anymore. Resend. Do that. Send. Let's send 4 of those so it stays aligned. Dat plus equals. What was this libc of? It was a put. So we just want to send q libc minus puts plus libc plus q libc. Minus puts plus the address of NSH is 0 in there too. We can put 0 because that's not valid string magic. Okay, cool. So let's see. We can put zeros because we don't need to type that's a string. Let's send a 0 because we can. Fgets is not going to turn in on zeros, it will turn in on /n. So still need to figure out where bin sh is. Not spelt wrong bin sh, but real bin sh. Now s.send dat plus n s.send. Right, so the thing we're going to need is going to be like a stack pivot jumper. We'll find that in a second, whatever. So this is actually the address we're going to jump to here. Whatever, I was just trying to guarantee it's right. Alright. Yes, because I didn't see the address there. It's blocked, should be blocked on that read. Cool. What I wanted to check if it was right, or go let's see and see. Yeah, okay. So when we get stack control, you know what? We're just gonna pad this out with a lot of. We're gonna stack not flag. Like, you know, like something like that is like a stack top sled, right? You can send a lot of those. Now we need to add some big number to the stack and jump to it. 28 looks a little meager. Is there something bigger? And we have all libc too, so. Leave, I hate leaves. Let's try that. forget. It's probably gonna crash. Crash. The other question is where? What? Yeah. Alright, so let's see, we hijacked control. Yeah, we're not far enough. Okay. We just need to go a bit further. Didn't we tell it to display bytes before? No, those are what I want. That was libc. Gotta find a gadget in libc. Gotta find a gadget in libc. Oh. 83 C4. No, that's better. There we go, done. So let's see, minus. Oh, you know what? Sloppy coding, sloppy coding. Shell. Yeah, shell. Alright, cool. That was fun. That was real fun. Let's hit the real one now. Everyone's gonna have different libc offsets, so we gotta get a new instance. Yeah, nope. Yeah, libcsl, alright, cool, load. Yeah. Let's parameterize some of this. So we have puts equals that. System equals that. Message equals that. Gadget equals that. Let's do the replacements here. Let's call it gadget. These are all wrong for this libc. And we're plugging the other libc. Let's hit puts with puts. System. And we're gonna say let's find that gadget again. I'd like to see something. Yeah, it's a good gadget. Go.